Hello everyone, welcome back to Knowledge Bytes. So today we are going to understand one of the most important concepts behind ChatGPT, Amazon Nova, Claude or modern language models, that is tokenization. Have you ever wondered how AI actually reads your prompt? Does it understand complete sentence the way humans do? The answer is no. Before any AI model understands your text, it first breaks into the smaller pieces called tokens. Right? This simple process is foundation of natural language processing and large language model. So let's understand tokenization step by step. Now, so take a look at this example. Here we have a sentence called knowledge bytes teaches AI. So you and I naturally read this one sentence, complete sentence, but AI doesn't. Instead, it this first breaks down this sentence into the smaller pieces. So knowledge like bytes and teaches AI, and even periods becomes one of the other separate tokens. So this means AI reads the tokens, not complete sentence. So every prompt you type into the ChatGPT or Amazon Bedrock starts with this process. So this process is called tokenization. So now let's get into the what is the tokenization, right? So tokenization is a process of breaking text into the smaller units called tokenization, right? These tokens can be the complete words or part of the words or punctuation marks or numbers or even special numbers. So as shown in the workflow, the input text first goes into the tokenizer. The tokenizer split the text into the tokens, and then each token is assigned to the unique numerical number called token ID. The most important point, remember, AI models don't read sentence, they read tokens. So now let's look at the simple example. Our sentence is knowledge bytes teaches AI. First tokenization, first tokenizer, the sentence become five the tokens, right? So after tokenization, the sentence become five individual tokens. Notice that even the punctuation mark is also treated as a token because punctuation also carries meaning. So these tokens are converted into token IDs, allowing AI model to process the information. Although this entire process looks complex, it happens in just a few milliseconds whenever you prompt, right? So another example, right? So now look at the another example. Consider the word unbelievable. Modern large language models often split into the smaller meaningful pieces like unbelieve and able. This technique is called subword tokenization. So instead of memorizing millions of complete words, AI just learns reusable word pieces that can be combined, understanding new unfamiliar words. You can see similar example with the word like playing, international and disagreement, right? So this approach makes AI's models are very efficient and capable of supporting the multiple languages. Now let's understand this. So there is a question, right? So why tokenization matters, right? So or why tokenization so important? First, it converts human language into machine readable units. Second, it helps AI understand unknown or newly created words. Third, it reduces the size of the vocabulary, making models more efficient, right? Fourth, it improves the training speed and overall model performance. Fifth, it supports multiple languages through reusable subword patterns. And finally, it enables scalable AI applications like ChatGPT, Amazon Bedrock, search engines, and translation systems or virtual assistants. In simple words, tokenization is the foundation of modern AI language processing, right? So let's understand the with a real world analogy, right? So imagine someone gives you a whole pizza. So eating entire pizza at once is very difficult, right? So what do? So we cut into the slices. So each slice become much easier to handle, right? So the same way tokenization works exactly the same way. So instead of processing one huge sentence at once, so AI will divide it into the smaller pieces called tokens. So those tokens become token IDs, and then finally AI model process them into the understand and process them and understand the meaning. So breaking large information into smaller process always makes processing easier, right? So now let's understand the workflow, tokenization workflow. Now, so everything starts with user's input sentence, right? Next, the tokenizer breaks the sentence into the smaller individual tokens. Each token receives a unique token ID. Those token IDs are converted into mathematical vectors called embedding. Finally, the large language model processes those embeddings into understand the context and generating the intelligent response. This entire pipeline happening automatically within a few milliseconds. So when you interact with the AI models, right? Now let's get understand the token IDs. So computer doesn't understand the words, they understand the numbers. That's why every token receive a unique numerical number. For example, each token in a sentence maps to the specific token ID stored in a model vocabulary, right? Large language models may have vocabularies containing hundreds of thousands of, or millions of tokens, right? So so you remember, so the important thing to remember that, so AI process these token IDs, not the original words. So where tokenization is used, so you might have question everywhere, right? So the answer is almost everywhere. So it's used in ChatGPT, Claude, Gemini, Amazon Nova, or Amazon Titan, or machine translations, text summarization, sentimental analysis, or search engines, or speech recognitions, question answering systems, even code generation code, everything. If AI system works with the human languages, so tokenization almost everywhere, right? Let's get into the next way. So now let's connect with the connection with the AWS. So whenever you send a prompt to the Amazon Bedrock, the model automatically performs the tokenization before inference. The models are converted into token IDs, then into embeddings, and finally processed by the foundation models. So these embeddings can also be stored and searched using these services like Amazon Open Search services. Our services such as Amazon SageMaker help and build the train the models, and Amazon CloudWatch helps monitor their performance, right? Together, these AWS services provide end-to-end platform building intelligence services, right? So let's get into the other way, how this is topic is going to be covered in exams. Now, so here is a question. Before a large language model process a prompt, what is the first NLP step? The option A, embedding generation, the option B, tokenization, option C, fine tuning, option D, vector search. The correct answer is B. Always remember the sequence from text to tokens, and from the tokens to token IDs, from token IDs to the embedding, and then model response. So this pipeline is important, the concept, right? So let's look at the key takeaways what we learned today. Let's quickly summarize today's learning, right? Tokenization is the first step in natural language processing. AI models doesn't read sentences, they read tokens. Every token is converted into unique token ID. So those token IDs become embedding that capture the meaning, right? Large language models process those embeddings into generate intelligent responses. And every modern AI application, including ChatGPT or Amazon Bedrock or anywhere, Amazon Nova, begins with the tokenizations, right? So that brings us to end of this today's episode. In the next episode, we will explore tokens versus context window. So you will learn how many tokens a model can remember and why context windows matters, and how tokens limits effect to the AI responses, right? So if you found this video helpful, please like, share, and subscribe to Knowledge Bytes. Thank you for watching.